Hello all, I am Nalini Jagtap from Dr. D.Y. Patil Institute of Engineering Management and Research. Today I will be explaining here about P class, NP class problems, NP hard problems and NP complete problems. So the learning outcome after this video is you all will be able to understand P and NP class problems, categorize the P and NP class problems and decide the tractable and non-tractable problems. Let's have a quick overview of what are the polynomial and non-polynomial problems or P class problems and NP class problems. Generally, whenever we have a problem in our hand, we try to find out the solution for the problem, and that solution is written in an algorithmic format. Right now, these algorithms can be polynomial time algorithms or non-polynomial time algorithms, or in fact we can say the solutions are polynomial time solutions or non-polynomial time solutions. So polynomial time solutions are the class of a decision problems that are solvable in big O of P of n time. So this P of n is a polynomial of problems input size. So we'll say again, all problems that can be solved in a polynomial time is called polynomial time or class P problems. Some of the examples of class P problems are searching, a linear search, or a binary search which has the complexity as log to the base 2 of n, sorting like a merge sort which has a time complexity of big O of n log n. So all the problems which are solved in a polynomial time are called as a polynomial class or P class problems. There are problems which are NP class problems. Now for some questions there is no known way to find an answer quickly. But if the answer is provided to you, those answer can be verified very quickly. So the class of questions for which an answer can be verified in time is polynomial time is called as NP. The examples of NP problems are Sudoku problems, Hamiltonian cycle problem, vertex cover problems. So we have a huge number of NP class problems available with us. Now we'll see how this Sudoku is an NP class problem. So take this example of Sudoku. What happens in a Sudoku is we have given a block, and this block has to fill with the numbers 1 to 9. A number cannot be repeated in a block. In a similar manner, the number cannot be repeated in a row or in a column. Right? So now take example of this particular block. In this block, we have 6 vacant places. Right? To fill this first place, we have 6 options available with us. Correct? We have either we can fill here 1 or 2 or 4 or 5 or 6 or 8. So we have 6 options available with us. So we can have 6 factorial combinations for us to fill this particular box. Then we have a 5 factorial combinations. Here we have 4 factorial combinations. Here we have 3 factorial, 2 factorial and 1 factorial combinations to fill this one particular block. Like this we have 9 blocks available with us, and while filling a block, again we have to take care that particular number is not to be repeated in a row or in a column. Right? So factorial, this particular is giving us a time complexity in a factorial time, which is an exponential time complexity to solve this Sudoku problem. Right? But suppose we have a solution available with us. Say somebody has said like this particular block to be filled with a 5. This is the solution. Now that solution can be verified very easily. How to verify? That 5 should not be repeated in this particular block and in this row and in this column. So to verify solution is an easy task. It is a polynomial time task. So solving the problem is difficult, but if solution is provided, then verifying the solution is easy task. So this is how I have explained the NP class problem with the example. Now let's have a quick review. The first question for the quick review is dash dash is a class of a decision problem that can be solved by non-deterministic polynomial algorithm. Yes. Can you think of the answer for this? You have options as NP, P, hard or complete. So it is says as non-deterministic polynomial. What does it mean? We cannot solve a problem in a deterministic time. but if solution is available, it will be verified in a polynomial algorithm, which we have seen just now. So the answer for this is yes, it is NP. The second question is, what does the NP stands for in a complexity classes theory? Right? So what does this NP stands for? Now have a quick review again. The NP stands is for, is it a non-polynomial? No. Is it a non-deterministic polynomial? Yes, it is a non-deterministic polynomial. Good. Now we'll move ahead quickly. So we'll see NP class, which is verified in a polynomial time. P class solved and verified in a polynomial time. So this whole set is a NP class. In this whole set we have some problems which belongs to P class, so which can be solved and verified in polynomial time. Right? So the problems which belong to this particular class are tractable problems, and problems which belongs to this big class, which is the NP class, are non-tractable problems. Right? So let's have the quick overview on this. So problems that can be solved in a polynomial time are known as, yes, the options are intractable, tractable, decision complete. Right? So again I will repeat the question. Problems that can be solved in a polynomial time are known as, yes, the answer is tractable problems. The second question is, what are the examples of polynomial problems? What are the polynomial problems? Okay, let's have a quick recap. What are the polynomial problems? The problems which are solved in a polynomial time are polynomial problems, right? So finding a factorial, it is a polynomial problem, right? Matrix multiplication, again the time compression is n cube, so it is a polynomial time, right? Insertion sort, of course it is n square, so it is also a polynomial problem, right? So answer for this is all of above. The third question for the quick review is, which of these are non-tractable problems? Right? So Hamiltonian cycle, traveling salesperson problem, and Tower of Hanoi. I hope you all know these problems, right? So these all problems which cannot solve in a polynomial time. These are difficult problems. We don't have a solution in a polynomial time for these problems. So all of these problems are non-tractable problems. With this, we have covered what is N class, NP class, and what are the tractable and non-tractable problems. Thank you.